Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson number 3 on the commutative and associative properties. I'd like to remind you before we begin that the worksheet for this lesson and a homework set can be found by clicking on the lessons or on the video's description. Also, you can find it on our website, www.emathinstruction.com. As well, let me remind you that at the top of each worksheet there's a QR code. You can scan this code with a smartphone or with a tablet and it will take you directly to this video. But let's begin. In order to really understand algebra, algebraic expressions, equations, manipulating them, without thinking that it's just a bunch of symbol manipulation, symbols flying here or there, what you really have to understand is the way that numbers behave and the way that they combine with the various operations of addition, subtraction, multiplication, and division. In the last lesson, we saw this a little bit in terms of the order of operations. But in this lesson, we're going to get at two very important properties of numbers, the associative property and the commutative property of addition and multiplication. But let's take a look at the first exercise, because I think this really gets to the heart of the matter. It says, add the following numbers without using a calculator. It says, hint, although order of operations tells us that we should add from left to right, in other words, we should do 3 plus 9, get an answer, then do plus 4, get an answer, then do plus 2, get an answer, etc. Think about an easier way to sum these numbers. Sum meaning to add up, right? Sum means to add up. All right? Show how you sum them. So, take a moment and see if you can figure out a very, very easy way to add these numbers together. All right, let's go through it. I don't know if you caught this, but what we can do is we can see, well, I've got 3 plus 7, right? I've also got 9 plus 1. I've also got 4 plus 6, and I've got 2 plus 8. Now what I could do is I could really think of it like this. I could add those two together, those two together, those two together, those two together. And of course the reason that that's an advantage is that's 10, that's 10, that's 10, and that's 10. So I add them all together and I get 40. Now that just seems crazy. We just spent an entire lesson talking about order of operations and how you have to do things in a particular order. And yet for some reason, I decided I would flip-flop this addition all over the place. And I would just decide which two numbers to add together in whichever order I decide. So I'm going to add the 3 to the 7, the 9 to the 1, the 4 to the 6, the 2 to the 8, and then I'm going to add those all together. My ability to do this gets into these properties that I was talking about, and we're going to review those in the next exercise. So write down anything you need to right here before I scrub out all the text. All right, here we go. Let's take a look at the next exercise. All right, so all of these properties have important names, and they are names that we want you to know. Terminology is important. So the first property is called the commutative property of addition. 8 plus 4 gives the same sum as 4 plus 8. In other words, it doesn't matter whether I do 8 plus 4 or 4 plus 8, I get the same answer, which is of course 12. The commutative property of addition. When I'm adding two numbers, just two, I can add them in either order that I want, right? And this is helpful because if you're thinking about what 3 plus 17 is, it's kind of hard to think of being at 3 and adding 17, right, to get up to 20. It's much easier to think about, I got 17, I add 3 more, I'm at 20, right? And it really doesn't matter whether I have 8 baseball cards and I add 4 baseball cards, or whether I have 4 baseball cards and I add 8 baseball cards. Now the same thing works with multiplication. The commutative property of multiplication, 6 times 3 gives me the same product as 3 times 6. Both products are equal to 18, right? Now again, a lot of students like to use this, especially in helping them remember their multiplication table, because that means you only have to remember kind of half of it, if you will, right? If you know that 3 times 7 is 21, well then later on when you have to do 7 times 3, you know it's 21, right? Now, the associative property, this is interesting. So commutative property works when you have two things that are either being added or multiplied, and you can think about them in either way. The associative property always involves 3 numbers or 3 expressions or 3 variables, right? And it basically says the following. Let's take a look at addition. If I look at this, 3 plus 5 plus 9, right? What that implies is I'm really supposed to do 3 plus 5 first and then add 9. The associative property says, hey, look, I got 3 numbers. I can add any 2 of them I want first, right? Think about this for a moment. If I do this, right, I get 3 plus 5, which is 8. Then I add 9, and I get 17. On the other hand, if I do this, and I add 5 plus 9 first, I'll get 14. Add 3, I also get 17. So the associative property of addition says that if I have 3 things added together, 10 plus 8 plus 4, right? I can add any 2 of these I want. Any 2 I want before I add the third one. So I could do 10 plus 8, or I could do 8 plus 4. Technically speaking, in order to do 10 plus 4, I'd have to use the commutative property to flip-flop this addition. But we'll get into that a little bit more later. Associativity, that makes me sound smart, also works with multiplication. In other words, if I'm multiplying 3 things together, 2 times 5 first, then times 7, that's going to give me the same thing as if I do 2 times 5 times 7. Let's look at that for a second. 2 times 5 is 10. Then if I multiply by 7, I get 70. On the other hand, if I do 5 times 7 first, I get 35. Now I know that's a little bit harder, but 2 times 35 is also 70. All right. These two properties, the commutative property of addition and multiplication and the associative property of addition and multiplication, are very, very important properties. I'm going to use them a lot. I'm going to cite them a lot so that you get used to their names and used to how to think about them. Although hopefully this isn't the first time you've seen them. I'm going to scrub out the text, so copy down what you need to. All right, here I go. And it's gone. Let's go on to the next problem. Exercise 3 says, give an example that shows that subtraction is not commutative. So this is very important, right? We've talked about the commutative property of addition and multiplication and the associative properties of addition and multiplication, but not of subtraction and not of division, right? So addition is commutative because 3 plus 5 is 8, and 5 plus 3 is 8. But watch what happens when we do subtraction, right? Let's go with the same 2 numbers. 5 minus 3 is 2, but 3 minus 5 is negative 2, so not commutative. Now, why do I even bring this up? Why do I bring it up at all? I bring it up because a lot of times we're going to want to manipulate algebraic expressions. Remember, an expression is just a combination of numbers that we know and numbers that we don't know. Maybe we know them all, maybe we don't know any of them, but it's just a combination of them using addition, subtraction, multiplication, division, and other operations, right? And we're going to want to be able to manipulate those using the rules of numbers and operations, like order of operations and like the commutative property and the associative property. So subtraction presents us with a problem. We can't rearrange it. But subtraction can be commutative if you turn it into addition. And that's what exercise 4 is all about. Exercise 4 says, change the following expression involving addition and subtraction into one only involving addition, then use the commutative and associative properties to quickly determine the value of this expression. Through this, please review some properties of negative numbers. So first, let me review how to change subtraction into addition. Why don't we stick with this 5 minus 3 business. 5 minus 3 can be changed into an equivalent addition by simply adding the opposite of the number we're subtracting. So 5 minus 3 is the same as 5 plus negative 3. Either way, we get 2. Let me do another one of these. Let's say I had even something like this. Let's say I had 8 minus 12, right? That would be the same as 8 plus negative 12, which would be then negative 4. Got it? So let's do this one. Let's change everything into addition. So that's going to be 7 plus negative 3 plus 8 plus negative 2. Ooh, here's a subtraction. Plus, ooh, that does not look like a plus at all. Let's get rid of that. Plus negative 6 plus 1. Ooh, here comes the hard one. This is tricky for most people. Subtracting a negative 3 would be the same as adding a positive 3. Remember, we always add the opposite. So the opposite of negative 3 would be positive 3. Now, the reason that this is so nice is now using associative and commutative properties of addition, I can write this any way I want. Often what I like to do is I like to group all the positives together. So watch this. Here, let me go in red. That'll help us see it. Positive, 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 positive. So 7, 8, 1, 3. Then let's go negative. Go different color. Negative, negative, negative. So plus negative 3, plus negative 2, plus negative 6. And watch what I'm going to do next. I'm going to actually use the associative property. Associativity says I can group these addition in almost any way that I want. So 7 plus 8 is 15, plus 1 is 16, plus 3 is 19. Okay, here negative 3 and negative 2 is negative 5, plus negative 6 is negative 11, and now 19 plus negative 11 is 8. I'm going to be doing that a lot. I'm going to be changing subtraction into adding opposites quite often. I suggest you do the same thing because addition is way more flexible than subtraction. Subtraction, you have a problem. But addition, you can flip-flop, you can group in various ways. Commutative and associative properties. All right, I'm going to be clearing this out. Here we go. All right, next problem. So one thing that you've done in previous courses is you've combined like terms, and we're going to be working with that quite a bit this year. All right, so some real basic review. Let's take a look at exercise 5. In fact, my bet is you could probably do this on your own. So I'd like you to pause the video and see what you remember about this. If you don't remember it at all, don't worry, we're going to review it. But see what you can do, okay? Pause the video now. All right, let's go through it. Again, we're going to be looking at sort of a more formal basis for how to do this eventually, but really it boils down to this. 5x's really means that you've got x plus x plus x plus x plus x. I think I did enough. And 2x means that you've got 2x's. So obviously if I've got 5x's and I add 2x's, I end up having 7x's, right? Here it's a little bit trickier. If I have 7 positive x's and 3 negative x's, then I have a grand total of 4 positive x's. Likewise, if I have negative 8x's and negative 2x's, then in total I have negative 10x's. So just a little combining like terms. No different than combining oranges. If I have 5 oranges and 2 oranges, I have 7 oranges. If I have 7 oranges and I subtract 3 oranges, I have 4 oranges. I don't know about letter C. Anyway, one thing that the Common Core is going to challenge us to do is to explain our math. You know, previous curriculums in algebra really just had you manipulating symbols, solving equations, doing a lot of what we're going to do this year. But it was pretty rare that you had to explain things, justify things, list properties. Common Core is going to demand that of you. You're going to have to raise your game. So let's take a look at exercise 6. It says in the following exercise, we show how two linear expressions, we'll get into this word more, how two linear expressions are combined using various properties. List what those properties are. So here we want to understand why we can rewrite 3x plus 7 and 2x plus 8 without the parentheses, right? Why can we do that? Because with the parentheses, it means that we're adding these two first, adding these two first, then adding the totals together. Without parentheses, it really means I'm doing 3x plus 7 plus 2x plus 8. So what gives us permission to add in any order we want? That's going to be the associative. We're going to abbreviate property, and this is important, of addition. Because we didn't do anything with multiplication there, it was all addition. All right, now notice that this line and this line are the same. Okay, so now when we take this line and compare it to this, what happened? And what happened was we essentially said that 7 plus 2x was the same as 2x plus 7. We just took that addition and we reversed its order. That is the commutative property. And again, it's of addition. My F's are not looking very much like F's. All right, again, notice this line and this line are the same. And look what we're doing. Now we're saying, even though the addition normally would be 3x plus 2x, get a result, add 7, get a result, add 8, get a result, we're now going to group the 3x and the 2x together, and the 7 and the 8 together, and that is again the associative property. It's completely okay to abbreviate property as prop. Nothing here, that's just combining like terms. All right? So make sure you can not only recognize these properties, but that you, as you manipulate things, you're kind of constantly reminding yourself in your head of what property you're using. Really, really important. All right? We'll use them a lot more in lessons to come. But for right now, I'm going to scrub out the text, so pause the video if you need to. All right, here we go. And it's gone. Let's do a wrap. Actually, no, we've got one more problem to go. What was I thinking? Exercise 7. Combine the expressions below. Replace subtraction by addition of opposites if needed. So take a little bit of time and try to write these expressions in their simplest form by combining what you can and leaving what you can't. Okay? Pause the video now. All right. So you don't have to write down the properties, but I'm going to talk about them as I go. So what I'm going to do is I'm going to first rewrite this subtraction by 9 with an addition of negative 9. Then what I'm going to do is I'm going to use the commutative property to flip-flop this addition to make it into this addition. Finally, what I'm going to do is I'm going to use the associative property to group these two particular additions together. 4x plus negative 2x will be a positive 2x. 6 plus negative 9 will be negative 3. And we normally don't leave things this way. We would normally then write it as 2x minus 3. All right? Now, pause the video again and try letter B and letter C if you got letter A wrong or you were confused about how to do it. All right, let's go through it. Letter B. Again, what I'm going to do is I'm going to flip-flop this addition using the commutative property of addition. So it's going to become 10x plus 9 instead of 9 plus 10x. Then I'm going to use the associative property of addition to group those together. Negative 6x plus 10x would be a positive 4x, and 9 plus 3 is a positive 12. That's it. Oh, letter C's got a lot of subtraction. So I'm going to rewrite this as 4y plus negative 10 plus negative 7y plus negative 3. Now I do that simply because subtraction is not commutative or associative, but addition is. So now I can play around with this the way I did before. I'm going to use the commutative property of addition to rewrite that as negative 7y plus negative 10 plus negative 3. Again, using the associative property, I'm going to group these two additions together. 4y plus negative 7y is negative 3y. Negative 10 plus negative 3 is negative 13. And again, although that's a perfectly good answer, in all likelihood, we would want to leave it like this. Negative 3y minus 13. All right, now that is the last exercise. So pause the video now, write down anything you need to, because we are scrubbing the text. Bye-bye text. Okay, let's finish up. We're going to be doing a lot of manipulation of algebraic expressions in order to do a lot of different things, to see structure, to play around with ideas, to play around with equations and variables. Knowing the properties of the operations addition and multiplication along with the numbers, right, these commutative properties and associative properties, will be key in doing these manipulations. So be sure to know them. All right. Well, I want to thank you again for joining us for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler. And until the next lesson, don't forget, keep thinking and keep solving problems.